video, we're going to look at the gradient of linear lines. And so the gradient, what is the gradient? The gradient is the steepness or slope of a line. And in our formula for a straight line, y equals mx plus c, we're paying particular respect to m. M is the gradient. M is the letter representing the gradient. Okay? And there's two ways to calculate the gradient. There's one using a visual representation, i.e. we're taking it from the graph, as you can see here. There's also another way when you're given the coordinates first. But before we get that, I just want to draw your attention to this. So there's 4 different types of lines that we can have. Our black lines on this visual is our Cartesian plane lines. Okay, so they're our reference points. Cartesian plane, black lines. First one we're going to look at is the negative gradient. The negative gradient is any slope where the first, or any slope really, where our first left-hand coordinate is taller than all the remaining coordinates. So we always read graphs from left to right. So always in that direction, never right to left, never up and down, never in a diagonal fashion. We always read them left to right. So you look at this point here, you go, how does that point travel? Well, it goes down one and across one, down one and across one. And because it's constantly moving down, we know that it's a negative line. The next type of graph we're going to look at is a positive gradient. So positive gradient, our first coordinate, the next coordinate's up from it, and up and up. So that's how we know it's positive, because we go up and then across, up and then across. So we're going at a positive escalation. The next one that we covered in our last video on one intercept, drawing graphs using one intercept, is our zero gradient. And that's this one here, our zero gradient. So anything that is perfectly horizontal, running parallel to our x-axis, is our zero gradient, which then leaves our last gradient is our undefined gradient, and that is a gradient that runs perpendicular to our x-axis, so parallel to our y-axis, and that is an undefined gradient because we can't have a gradient that is perfectly vertical. We don't know the value of it. So undefined gradient, always perfectly vertical. Our zero gradient, always perfectly horizontal. So both of these run parallel to the other axes. So gradient, zero gradient, x-axis runs parallel to that. Undefined gradient, the y-axis. Our negative and positive can change. So they can rotate in both directions. They can become steeper or they can become flatter to the point where they're almost undefined or almost zero. So you can have any type of fraction. You could have a gradient of 1/100th, or you could have a gradient of 3. And you can have a fraction or a whole number gradient. And that will change how steep or how flat that gradient will be, the line will be. So that's the first thing we need to understand about our lines and our gradients, is what shape they're going to make. And it's really important that we can picture the line in our minds using the coordinates or using the equation before we graph it. So going back to this visual diagram, this graph, we're going to look at the blue line first. So how can we calculate the gradient of that line? Well, we use a rule where m is our gradient. M is equal to the rise of the line divided by the run of the line. And you need to make sure you pick 2 coordinates. It can be any 2 coordinates, but they must be coordinates. And so this graph is really nice and easy because the coordinates are mapped with the blue dot on the lines. So you can see with the red one, there's a nice long red line, but there's actually only 2 coordinates on that line, at 0, -5, and at 2, 0. we can't use any other point on those lines because they're not actually coordinates. The blue line has lots of coordinates. So let's choose this one here at C, and we're going to use the one up at D. I'm going to make it nice and big for you so you can see that this representation. So we're going to do it in black. We're going to go, actually, let's choose a different color. Let's do it in orange. We're going to go from C up. How do we get to that point D? We're going to go up. How many spaces do we have to go up? We have to go up 1, 2, 3, 4. From 1 to 5 is a rise of 4. Then we have to go across 1, 2. So we have a rise of 4 and a run of 2. Then 2 goes into 4 2 times. So our gradient is 2. If we look at this green line, if we start here at G and we go down to our point here on the x-axis, we're going down 1, 2, 3, 4. So it's a rise of -4. It's actually a fall. I'm going to do this one orange. M equals rise over the run of the line. So the rise is -4, and we know that because it's a falling line. Our first coordinate is above our next coordinate, so it's a negative trend. Then we go across 1, 2. So our run is 2 again, but our gradient this time is -2. And then lastly, with our red line, I'll do this one in red. Our rise, where our rise is 1, 2, 3, 4, 5. And our run is 1, 2. And we can leave our gradient in that form in 5/2, or we can change it to a mixed fraction of 2 1/2. So that's doing it visually. Using the graph, rise over run, how far is another coordinate from your starting coordinate? The other method is using the given points. So same thing in theory. Let's go back to black. So we know that we can find the gradient by dividing the rise of the line by the run of the line. And that is like dividing how far it moves vertically by how far it moves horizontally. I.e., y movement divided by x movement. And so in question 1, we have 2 sets of coordinates. We have 3 and 4, and we have 5 and 6. And I'm going to call 3 and 4 our first set. So I'm going to call them x1 and y1. And 5 and 6 are our second set, so it'll be x2 and y2. So we can calculate the movement by subtracting our x values from each other and our y values from each other. So again, following on what we set up here, where our rise is divided by our run, so how far it moves along our y-axis, divided by how far it moves along our x-axis, we figure that out by going y2 minus y1 divided by x2 minus x1. So in this case, y2 is 6, y1 is 4, x2 is 5, x1 is 3, 6 minus 4 is 2, 5 minus 3 is 2, 2 into 2 goes once, so our gradient is 1. In the second question, we have -3 and 6, 1 and -3. So again, I'm going to label these so I don't get confused. x1, y1, x2, y2. A common mistake I see is that boys or students, I said boys because I only teach boys, is they'll go x1, x2, y1, y2, and they muck up the pairings of the coordinates. So if it's easier, I would write 1 and 2 above it. So you remember, that's the first set, and that set belongs together. So it has to be x and y. x1, y1, x2, y2. And when you get into more advanced graphing, you might even have a third set of coordinates. You can have x3, y3. So in this one, always write out the rule. y2 minus y1 divided by x2 minus x1 is equal to -3 minus 6 divided by 1 minus -3. Double negatives. Hate to see them. -3 minus 6, we're at -3. We're going to move 6 back in the negative direction. We're going to end up with -9. 1 minus -3, negative, negative, positive. 1 plus 3, 4. So then we have -9 over 4, and we can leave that as m equals -9 over 4. Or we can say 4 goes into 9 twice with 1 over 4 and leave it as a mixed fraction. So that is how you calculate the gradient. This method that I just showed you is when you're given the coordinates. And the key rule is this one here, if you want to write that in your notebooks. The other method is using the rise over run, and that's the key rule there. Right, good luck.